We are going to start now the next lecture, lecture 2 of chapter 12, class 10th mathematics. It is areas related to circles. Now in this lecture we will talk about areas of combination of plane figures. So the first question we have is that this figure is given to us and it is given that this ABCD is a square and length of each side of this square it is 10 centimeter and semicircles are drawn with each side of the square as diameter. We are saying with AB as diameter, this semicircle is drawn over there. Next, as BC as diameter, this semicircle is drawn. Next, as CD as diameter, this semicircle is drawn. And last, as AD as diameter, this semicircle is drawn. We have to find the area of the shaded portion. Now, we are drawing this figure again over here. Suppose this is the square we are talking about. This region, this unshaded region, we have marked 1. This region we have marked 2. This is 3 and this is 4. We are talking about the area of the region 1 and 3. We are saying if we draw the semicircle about the diameter AD, this is the semicircle about the diameter AD, this thing we are talking about. And if we draw the semicircle about the diameter BC, this is the semicircle we are drawing about the diameter BC. What is the portion over here? This is the semicircle we are talking about. Second, we are talking about this BC. This is the portion we are talking about. We have marked these portions. This portion we have marked it as 1 and this portion we have marked it as 3. So we are saying the area of the square ABCD, the length of this side it is 10 centimeter. So the area of the square it is 10 square minus area of this semicircle. The radius of this semicircle will be 5 centimeter. So it is pi into 5 square. And the area of this semicircle it is pi into 5 square. So if we from the area of this whole square we subtract these two areas, we are left with this area 1 plus area 3. We are left with these two areas. So we are saying the area of region 1 plus area of region 3, that value is equal to the area of the square ABCD minus sum of the areas of the two semicircles. When we solve these values, we are getting it is 100 minus pi into, it is 5 5 is 25 into 250, and this comes out to be 100 minus 78.5 and this comes out to be 21.5 centimeter square. Similarly, if we calculate the area of region 2 plus 4, the area of the sum of these two regions, it also comes out to be 21.5 centimeter. Now, the area of all these four regions, we are talking about area of region 1 plus 2 plus 3 plus 4. The area of all these four regions, it is 2 times 21.5, that is equal to 43 centimeter square. So we are saying we have calculated the area of unshaded portion. The area of the square we have it is 10 into 10, that is equal to 100 centimeter square. So the area of the shaded portion will be 100 minus 43, that is equal to 57 centimeter square. Now the next question we have is, in the given figure, two circular flower beds have been shown on the two sides of a square lawn ABCD. So we are talking about a square lawn is there and there are two flower beds on both sides of the lawn, and it is given that if the center of each circular flower bed is the point of intersection O of the diagonals of the square lawn. So we are saying, suppose these are the diagonals of this square lawn, and this point it is the O. Now this is the center for these two flower beds that we have over here. We are saying these are not semicircles, these portions, these are not semicircle, these are just like the sectors, because the radius for these flower beds, it is this R. We are saying this is the radius for these flower beds. So we have first to find the sum of the areas of the lawn and the flower bed. So we are calculating, we have to calculate the area of this sector, we have to calculate the area of this second sector. Next we have to calculate the area of these two triangles, so that will give us the total area. One important thing to note over here, we are not saying that these are not semicircles. These are not semicircles because their center, they are lying at this point O. So we are calculating first the area of this sector. We are talking about this portion over here. The area of this sector will be pi r square into the angle that we will have over here. This is 90 degree because it is a square, and we know that the diagonals of the square, they bisect each other at 90 degree angle. So it is pi r square and it is 90 by 360. Now if we look at this triangle AOB, we are saying this is right angled at O. These two values, these are equal to R. Now we have this, the value of this AB, it is given 42 centimeter. So in this right angled triangle, we have R square plus R square is equal to 42 square. So 2 times R square, that is equal to 1764. So the value of R, we will get it, R square we will get it is 882. Now if we substitute this value of R square over here, the area of this sector we will get it is pi into 882 into 1 by 4. This is the area of one sector. Next, when we are talking about this sector over here, the area will be 2 times this. Next we are talking about the area of this triangle. So area of this triangle will, this triangle we are talking about, area of this triangle will be half base. This angle is 90 degree over here. We are talking about this triangle, that this is 90 degree over here, this is R, this is R. So the area will be 1 by 2 R square, and the value of R square we have, it is 882. How many such triangles we have? We have 2 triangles with us. The number of triangles we have, it is 2 triangles. So the total area we have, it is 2, this 2 and this gets cancelled. So what we are left with is, it is 882 pi by 2 plus 882, and on solving this you will get it is 882 into 11 by 7 plus 1, and this value comes out to be 126 into 18, and this is equal to 2268 meter square. So this is the area of this complete figure. Second thing we have to calculate is the sum of the areas of 2 flower beds. So we are saying the area of one flower bed, this flower bed, suppose we are talking about, its area will be the area of the sector we have calculated. The area of one sector we are talking about, it is pi into 882 into 1 by 4. This is the area of one sector, minus area of this triangle we have calculated. So the area of this triangle we are talking about, the area of this triangle is 1 by 2 into R square, that is 882. This is the area of one flower bed. How many flower beds we have? It is 2 flower bed we have. So this 2 gets cancelled, we are left with 2 over here, this gets cancelled. We are saying it is, the value we are left with is 882 is common. we are left with 11 by 7 minus 1, and the value comes out to be 126 into 4, and this gives us 504 meter square. So this is the sum of the area of 2 flower beds. Now in this next question we have A, B, C, D is the quadrant of a circle. We are talking about this A, B, C, D is a quadrant of a circle of radius 28 centimeter. 28 centimeter is the radius of this circle. Next, a semicircle is drawn with AC as the diameter. AC is the diameter, and this semicircle is drawn over here. We have to find the area of the shaded portion. So first of all, we are calculating this length AC, that will be equal to square root of 28 square plus 28 square, and the answer comes out to be 28 root 2. So the radius of this circle will be 14 root 2. Say it is small r. This value we are saying it is capital R. So area of this semicircle will be pi r square by 2. This is the area of this semicircle. Next, we are calculating the area of this sector. The area of this sector will be 1 by 4 times pi r square. Next, we are calculating the area of this triangle. The area of this triangle will be half r square, base into height. Base is also of length r. This is also of length r. So the area of this segment will be 1 by 4 pi r square minus 1 by 2 r square. The shaded portion we have is, we are saying this is the semicircle we have, and in this semicircle we have this sector over here. We are subtracting this sector. So the area of the shaded portion, this is the shaded portion we have. So the area of the shaded portion will be area of the semicircle minus area of the sector. When we substitute the values in this, we will get the answer is the area of this region over here. We are saying it is 22 by 7 into 1 by 2 into r square. It is 14 into 14 into 2. This is the value of r. So r square will be 14 into 14 into 2. Next, it is minus 1 by 4 into 22 by 7. The value of capital R we have, it is 28 into 28. Next, it is plus, it is 1 by 2 into 28 into 28. On solving these values, on solving all these values, you will get the answers as it is these three values, and the final answer you will obtain, it is 392 centimeter square. So this is the area of the shaded region. Next is find the area of the shaded region in the given figure, where a circular arc of radius 6 centimeter has been drawn on vertex O of the equilateral triangle whose sides are 12 centimeter. So we are talking about the area of the equilateral triangle. It is root 3 by 4 into side square. So the area of this equilateral triangle, this portion we are saying, it is root 3 by 4. This angle over here we are talking about, this angle over here, this will be 60 degree. We are talking about the area of this equilateral triangle. So it is side is 12 into 12. This is the area of this equilateral triangle. Next, we are saying the area of this whole circle, that will be pi r square, and that is equal to pi into 6 square. Now what we are left with is, when we are talking about the area of this whole circle, this portion is covered. This portion is covered. When we are talking about the area of this triangle, this portion is covered. So basically this portion is covered twice. So we are subtracting the area of this portion from the whole answer. So we are saying the area of this portion we are talking about, the area of this portion will be pi r square into 60 by 360. That comes out to be 1 by 6 pi r square. So what is that final answer that we will have? It is root 3 by 4 into 12 into 12, area of this triangle, plus area of the circle, it is 22 by 7 into 6 into 6, minus, we are saying this portion is covered twice. Once it is covered in the area of the circle, once it is covered in the area of the triangle. So we are subtracting the area of this portion, and the area of this portion is 1 by 6 into 22 by 7 into 6 into 6. On solving these values, we get it is root 3 into 36, plus on solving this value, you will get it is 36 pi. On solving this value, we are getting it is minus 6 pi. These two values will give us 30 pi. We will substitute the value of root 3 as 1.73 and the value of pi as 3.14, because these two values, these are given in this question, that we have to take these two values in this form, and on multiplying these terms, you will obtain the final answer as 156.48 centimeter square. Next is, in the given figure, A, B and C, D are the diameters of a circle. This A, B and C, D, these are the diameters of a circle with center O. The center of this circle, it is O, perpendicular to each other, and these two, these are perpendicular to each other. OA is the diameter of the smaller circle. This OA is the diameter of the smaller circle. If OB is equal to 7 centimeter, find the area of the shaded region. So this length OA is also 7 centimeter. So the radius of this circle will be 7 by 2, that is equal to 3.5 centimeter. So the area of this circle will be pi into 3.5 square, or we are writing it is 22 by 7 into 7 by 2 into 7 by 2. This is the area of this circle. Second, we are talking about the area of this semicircle over here. This circle, semicircle we are talking about, this whole portion, we are saying the area of this portion will be pi into radius over here, it is 7 square, and it is half of this, so it is 22 by 7 into 7 into 7 by 2, so it is 11. These two gets cancelled, and we are left with is 77 centimeter square. This is the area of this semicircle. Now next thing we have to calculate is the area of this triangle. We are talking about this triangle over here. The area of this triangle is the base of this triangle. We are talking about the triangle in this form. This is C, D, it is over here. This is B and O, and it is given that these two lines, these are perpendicular to each other. So the length of this side will be 14 centimeter and height of this triangle is 7 centimeter. So area of this triangle is half base into height, so that is equal to 49 centimeter square. So area of this portion, we are talking about, area of this portion will be 77 minus 49, that is equal to 28 centimeter square. If we solve this value, this 7 get cancelled, this 2 gets cancelled, and we are left with this 38.5 centimeter square. So combining both these areas, this area is 38.5 centimeter square, this is 28 centimeter square. The total area we have, it is 38.5 plus 28, that is equal to 66.5 centimeter square. Next we have to calculate the area of the designed region in the given figure, common between the two quadrants of circles of radius 7 centimeter each. Now if we look at this figure, we are talking about this is the whole region we are saying, and suppose this is the line we are talking about. This is the line we are saying. We are talking about this AEC, this portion. This is the point A, this is point E, and this is point C, and this is the line AC we are saying. So if we want to calculate the area of this portion, so what we have to do, we have to calculate the area of ACE, this whole sector, and we have to subtract from it the area of this triangle, and we will obtain the area of this region. So the area of the sector that we will have, it is 1/4 of the circle, so it is 1 by 4 into pi into radius of the circle is 7 square. This is the area of the sector, and we are subtracting from it, this is 90-degree angle over here, so area of this triangle will be half, base is 7 and height is 7. There is. So these are the value we are saying, both these values, these are 7 and 7. Now this is the area of this much portion over here. In this figure, if we are saying this is the area of this much portion, the area of this second portion we are saying it is also equal to this, so we multiply this with 2 to obtain the area of this complete shaded region, and on solving this we will get it is 2 into 1 by 4 into 22 by 7 into 49 minus 49 by 2. So this is equal to 2 into 77 by 2 minus 49 by 2, and on solving this you will get the answer is 28 centimeter square. So this is the area of this design. Next is, in a circular table cover of radius 42 centimeter, a design is formed leaving an equilateral triangle ABC in middle as shown in figure. Find the area of the design. So radius is given over here. So when we are talking about radius, it means this OB, OC and OA, all these lengths, these are equal to 42 centimeter. So what we are going to do is, we are going to find the area of the circle. Area of the circle will be pi into 42 square, and next thing we have to do is, we have to find the area of this equilateral triangle, and if we could find the area of this equilateral triangle, then we subtract these two values. Now if we look at, to find the area of this equilateral triangle, we look at this triangle over here. We are saying this is the triangle ABC we are talking about. We have joined this B and C to this point O, then the angle at the center over here, these are of measure 60 degree. This OB length, when we are talking about, this OB length is given to be 42 centimeter. Now if we write the value of cos 60 degree corresponding to this angle we are talking about, we are writing the value of cos 60 degree. So that is equal to OD over OB. So the value of OD we get, that is equal to cos 60 is 1 by 2 and into OB, and the answer we get, OB length is 42. So the answer we get for this, it is equal to 21 centimeter. So we are saying this length OD we have, this is 21 centimeter. Next we are calculating the value of sin 60. So the value of sin 60 will be BD over OB, and the value of sin 60 we have, it is root 3 by 2. So we get that the value of OB we have, BD we have, I think the value of BD that we get, it is root 3 by 2 into OB is 42. So the answer we get, it is 21 root 3. So this base BC, the length of this base BC, this will be 42 root 3 centimeter, and value of this height over here, this will be this OA length, this is 42, OD length we have calculated, it is 21. So the answer we are getting, it is 63 centimeters. So we are saying the area of this equilateral triangle will be half base of this triangle, it is 42 root 3 into height of this triangle, it is 63. or you can use the formula, it is root 3 by 4 into side square. The length of the side we have, it is 42 root 3 square. You can use either of these two formulas, you will get the same answer. Now the calculation, these are shown on the next slide. Now we are saying that the area of the design that we have, it is area of the circle minus area of the equilateral triangle. So it is 22 by 7 into 42 into 42, 1.73 into 42 root 3 square. On solving these values, you will get the answer in the form, it is 5544 minus 2288.79. So the required area we have, it is 3255.21 centimeter square. Now next we have is, in the given figure, ABC is a right angled triangle, right angle at A. This triangle we are saying this is right angled at A, in which AB is equal to 6 centimeter. This length is given to be 6 centimeter. BC is given to be 10 centimeter, and I is the inner center of triangle ABC. That is, it is the center of the circle which touches the side of, which is inside this triangle, and it touches all the three sides. So find the area of the shaded region. So the basic thing we have to do is, the area of this triangle we can calculate. It is easy to calculate the area of this whole triangle. We are saying we have to calculate this side. So the value of this side, it is 100 minus 36 square root, and the answer comes out to be square root of 64, that is equal to 8 centimeters. So area of this triangle will be half base into height, and this comes out to be 24 centimeter square. Now by the definition of the in circle, we know that if we join this point O to this point over here, we join this point O to this point over here, and we join O to this point over here, then all these angles, these are of measure 90 degree. You can also look at this result from the perspective of the tangents. We are saying it is a tangent, and we are joining it tangent to this circle, and we are joining the center. So these angles will be 90 degree angles. The next thing we have done, we have joined these points. We have joined the point I to this point A, I to B, and I to C. Now we are saying this, suppose these points we are naming M, this point N, and say this point we are saying this is L. These are the 3 points we are talking about. So the area of these triangles, when we are calculating the radius of this circle, we are saying it is R. Now if I am talking about the triangle ABP or ABI, I am talking about, this is the point I, the in center. The area of this triangle will be half base of this triangle is AB, and height of this triangle is R. Next we are talking about the area of the triangle ACI. We are talking about the area of this triangle. So the area of this triangle will be half base of the triangle, it is AC, and height is R. And third, we are talking about the area of the triangle BIC. We are talking about the area of this triangle. The area of this triangle will be half into BC into R. If we add these 3 values, we will get half AB plus AC plus BC into R. And this value should be equal to 24. That is the area of the complete triangle. Now AB plus BC plus CA, this value is, we are saying it is 6 centimeter, 10 centimeter, and this side it is 8 centimeter. So the sum of all these sides, it comes out to be 24 centimeter. So we get 1 by 2 into 24 into R is equal to 24. So the value of R we get, it is equal to 2 centimeter. So we are saying the radius of this circle is 2 centimeter. So the area of this circle is, we are talking about the area of this circle, we have area is equal to pi into R square, it is 2 square, and on solving this we will get it is 3.14 into 4, that is 12.56. So the area of the shaded portion will be the difference of these two, and difference comes out to be 11.44 centimeter square. So this is the area of the shaded portion, the required area. Now the next question we have is, in an equilateral triangle of side 12 centimeter, a circle is inscribed touching its sides. Find the area of the portion of the triangle not included in the circle. So first of all, we are talking about the sides of the triangle. They are of length 12 centimeter and it is given that it is an equilateral triangle. So we know that the area of this triangle will be root 3 by 4 into 12 into 12. Now this area, this comes out to be 36 root 3 centimeter square. Now same area we can calculate with the formula 1 by 2 times BC into AD, because AD will be the perpendicular over here and this value is equal to 36 root 3 and we are saying it is 1 by 2 into the length BC is 12, AD we want to calculate, it is 36 root 3. So the value of AD we have, it is 36 root 3 into 2 by 12. So the answer we get, it is 6 root 3 centimeter. This is the length AD we are saying, it is 6 root 3 centimeter. Now by the property of the in circle, we know that the ratio of these two lines OA is to AD, this should be 2 is to 1. It means if this length is 2k, then this length is k. So we are writing 3k is equal to 6 root 3. This gives us k is equal to 2 root 3. So the length of this portion we are talking about OA, that is equal to 2 into 2 root 3, that is equal to 4 times root 3, and this OA gives us the this value over here, this OA, and this OD value we have, we do not need OA, basically we require OD. So we are saying this OD value we have, it is equal to 2 square root 3. So the area of this circle will be, area of this circle we are saying it is pi into 2 root 3 square. This is area of a circle and the answer comes out to be pi into 4 into 3. So it is 12 pi, and when we calculate these values we will get the answer is 37.68 centimeter square. When we calculate the area of this triangle, it is 36 root 3. We are talking about this value over here. It is 36 root 3. When we substitute the value of square root 3 as 1.73 and we multiply these terms, we will get the answer is 62.28 centimeter square. So what we get is, this is the area of the circle, this is the area of the triangle. So the area of shaded portion we have, so area of shaded portion, that is equal to 62.28 minus 37.68 and it comes out to be 24.6 centimeter square. Next we have is the area of an equilateral triangle is 100 root 3 centimeter square. So area of the equilateral triangle means, suppose the side of the triangle, its length is A. So the formula for the area we have, it is root 3 by 4a square, that is equal to 100 root 3. Root 3 gets cancelled. We get a square is equal to 4 into 100. So the value of a we have, it is 2 into 10, that is equal to 20 centimeters. Next is taking each vertex as center. A circle is described with radius equal to half the length of the side of the triangle as shown in the figure. So by taking the half of these lengths as the radius, these circles, these are drawn over here. This is one circle, this is second circle, and this is the third circle. Find the area of the part of the triangle which is not included in the circles. So we have to calculate this portion we are talking about, formed with these circles. We have to calculate the area of this portion. So if we look at this portion, we are saying we have an equilateral triangle. In this triangle we have some arc over here, an arc over here, and another arc over here. These are the three arcs that we have. So we are saying the area of this triangle is given to be 10 square root 3 centimeter square. Now if we calculate the area of this portion, any one of these portions, the angle over here it is 60 degrees. So area of this portion will be the area of the whole circle that we will have, it will be pi into 10 square. The radius of this circle, this whole length is 20. The area of this portion will be 10 centimeter, and it is multiplied by the angle we have, it is 60 over 360. Now how many such sectors we have? We have 3 such sectors. So the answer we get, it is upon 6. So it is 3 into 22 by 7 we will not take, we will take it is 3.14 into 100 into 1 by 6. On solving this, you will get the area of these 3 sectors. We are talking about area of this plus area of this plus area of this region. The area of triangle is given to be 100 root 3, that is equal to 173.2 centimeter square. On solving this value, you will get the answer is 157 centimeter square. We are saying on solving this value, you will get the area of these 3 sectors is 157 centimeter square. So on subtracting these values, we will get the area of this portion. This is equal to 16.2 centimeter square. Now the next question we have is a trapezium ABCD is given to us with AB parallel to CD. These two sides, these are parallel to each other. It is given that the length of this AB is 7 centimeter. This BC length, this is 7 centimeter. DE length, this is 4 centimeter. This BE is the arc of the circle. So this EC length, if this is 7 centimeter, then this is also 7 centimeter length. So this complete length we have, it is equal to 11 centimeter. Now if we look at this triangle BLC, the angle over here, it is 60 degree. So if we write the value of sine 60, we will get it is BL over BC, and the value of sine 60 is root 3 by 2. So we get the value of BL is equal to root 3 by 2 into BC, that is equal to into 7. And on solving this, we will get the answer is 6.05 centimeter. This is the length BL that we have. Now we are talking about the area of the trapezium. Area of the trapezium, the formula we have, it is half sum of the two parallel sides, it is 7 plus 11 into the height, it is 6.05 centimeter. This is area of the trapezium. On solving this, you will get the answer is 54.45 centimeter square. Next we are talking about this portion. We have to subtract this portion from the area of the trapezium. The area of this portion will be, this is the sector, so the area of this circle, the radius is 7 centimeter. So it is pi into 7 square, and the angle we have, it is 60 degrees. So it is 60 over 360. This is the area of the circle, and this is the part of the circle we are using. On solving this, we are writing it is 22 by 7 into 7 into 7 into 1 by 6. When you multiply these values, you will get the answer is 25.66 centimeter square. So the area of the shaded portion will be 54.45 minus 25.66, that is equal to 28.79 centimeter square. So this is the area of the shaded portion. Now next we have is in the given figure, ABCD is a trapezium in which the side A, B and DC, these are parallel to each other. The length of AB is given to be 18 centimeter. Length of DC is given to be 32 centimeter. And the distance between AB and DC, it means the perpendicular distance between these two, it is given to be 14 centimeter. If arc of equal radii, the radii over here, these arcs, it is 7 centimeter is given to us. we have to find the area of the shaded portion. So first of all, we are writing the formula for the area of the trapezium. It will be half sum of the two parallel sides into the distance between them. It is 14. Next, we are writing the area of these arcs we are talking about. These are 4 arcs. We are saying that there are 4 arcs. So if we look at all these 4 arcs, suppose this angle we have, it is theta 1, this angle we have theta 2, this angle it is theta 3, and this angle it is theta 4. It is a quadrilateral, so we have theta 1 plus theta 2 plus theta 3 plus theta 4. If we join these 4, you get the answer. It should be 360 degree. It means if we join these 4 arc sectors I am talking about, if these 4 sectors we join, we will get the complete circle. So the area for these 4 sectors, the combined area, the sum of the area of these 4 sectors, we will have, it is equal to the area of the circle, that is pi into radius of the circle is 7 square. So it is 22 by 7 into 7 into 7. On solving this value, we will get it is 7 over here, and the final answer we are getting, it is 350 centimeter square. This is the area of the trapezium. On solving this value, we will get the area is 154 centimeter square. This is the area of the complete circle, that is sum of the area of these 4 sectors. So the area of the shaded region will be 350 minus 154, that is equal to 196 centimeter square. So this is the area of the shaded region. This is the area of the shaded region. Next we have is find the area of the shaded region in the figure given below. So this is a square given to us. ABCD is a square that is given to us, and the sides of this square, they are 14 centimeter. So area of square, that will be 14 into 14, that is equal to 196 centimeter square. Now these distances, these are given to be 3 centimeter. These all distances are given to be 3 centimeter. And suppose we are saying that the radius of each semicircle is equal to a centimeter. We are saying the radius of each of this is equal to a centimeter. Then what we will have is, this length will be a, this length will be, the second portion we are talking about, this length over here, this is a. After this length will be a. After this length will be a. So sum of all these lengths we are talking about, the sum of all these lengths, it is 3 plus 1, 2, 3, 4 times a plus 3, that is equal to 14. So we got 4a is equal to 14 minus 6, and this comes out to be 8. So the value of a we get, it is equal to 2. So we are saying that the radius of all these circles, semicircles, we are saying it is 2a. So the area we are talking about for these semicircle, we are saying for this circle and this circle, they will form one circle. If I am talking about this upper semicircle and this semicircle, they will form another circle. So how many circles we have? We have total, we have 2 circles. So the area of these 2 circles will be 2 times pi r square, that is equal to 2 into 22 by 7 into 2 square. When we are talking about this square over here, the side of the square, that is equal to 2 times a. Each side of the square is equal to 2 times a, and area of this smaller square will be equal to 2a square, that is equal to 2 into 2 square. The area over here, that will be 2a square, that is 4 square, that is equal to 16 centimeter square. On solving this value, we are talking about the semicircles. So 2 complete circles, 4 semicircles are there, it means there are 2 complete circles. So the area when we calculate is 25.12 centimeter square. So the area of the shaded portion will be the area of the square, that is 196, minus area of this smaller square, it is 16, minus area of the 4 semicircles, it is 25.12, and the answer comes out to be 154.88 centimeter square. So we are saying the required area is 154.88 centimeter square. Next is 3 horses are tethered with 7 meter long rope at the 3 corners of a triangular field having the sides of this triangular field, they are given to be 20, 34 and 42 meters, and 3 horses, their length of their rope, it is 7 meters. Find the area of the plot which can be gauged by the horses. Also find the area of the plot which remains ungauged. So suppose the angles we have over here, the angles of this triangle, they are theta 1, theta 2 and theta 3. These are the 3 angles corresponding to this triangle. Now we are saying the sum of these 3 angles, theta 1 plus theta 2 plus theta 3, the sum of these 3 angles will be equal to 180 degree. Now suppose we are talking about 3 portion. This is angle C. We are saying we cut this portion from here and we are talking about, say this is the angle C we are talking about. This is the portion corresponding to the angle C. At C, that is theta 3 degree angle is there. Next we are talking about the portion corresponding to the angle A. We are keeping this tip at, this is C, then next we are keeping the tip at A and we are saying this is the angle corresponding to A. And third thing we are saying, this is the B. We keep the tip over here and we are talking about this is the angle corresponding to theta 2. So what we get is that the sum of all these 3 angles is equal to 180 degree. Their radius, they are same, 7. So it means we are saying when we combine these 3 values, the sum of all these 3 angles, that is equal to 180 degree. It means this is a semicircle. Now we have to calculate 2 things. One is we have to calculate the area of this triangle. So to calculate the area of the triangle, the sides are given. So we are going to use the Heron's formula. We are calculating the semi-perimeter. It is 1 by 2 times A plus B plus C. The answer you will get, it is 48 meter. Next we are calculating S minus A. It is 28. S minus B, it is 14. And S minus C, it is 6 meters. We substitute these values in the Heron's formula. We are talking about Heron's formula. It is square root of S into S minus A, S minus B, S minus C. When we substitute these values, you will get the area of this triangle. It is 336 meter square. From this result, we are saying the combined area of these 3 portions, that is equal to the area of the semicircle. Now this semicircle, it becomes 1 by 2, 22 by 7 into r square. R square means it is 7 into 7. So on calculating these values, the answer we will get, it is 77 meter square. If you are finding it difficult to solve or understand in this way, you can look the answer over here. You can refer these values. We are saying the angles are theta 1, theta 2 and theta 3. So corresponding values of area we will have in this form. Now we take pi r square over 360 common from all these values, and what we are left with is theta 1 plus theta 2 plus theta 3, and the value of theta 1 plus theta 2 plus theta 3 we have, it is equal to 180 degree. On substituting this value, we will get the answer is 77 meter square. So this is the area of this triangle, this sector, these 3 sectors combined. This is the combined area of these 3 sectors. So we are saying we have to calculate 2 values. One is the area in which horse is grazing. So the area is 77 meter square. So the left area we have, whatever the area left we have, it is the area of the triangle minus area of these 3 sectors, and the answer comes out to be 259 meter square. So these are the 2 required values. Next we have is the inside perimeter of a running track as shown in the figure is 340 meters. the perimeter of this inside track, it is given to be 340 meter, and the length of each straight portion, the straight portion we are talking about, its length is 60 meter, and the curved portion are semicircles. These curved portions we are saying these are the semicircles. If the track is 7 meter wide, the width of this track is given to be 7 meter. Find the area of the track. Also find the outer perimeter of the track. So when we are talking about, say, the radius, we are talking about the two radius over here. This is this portion we are talking about. The length of this portion is given to be 60 meter. Suppose the inner radius that we have, that is equal to small r, and the outer radius we have, that is equal to capital R. Now the perimeter of the inner portion is given to us. So what is the perimeter of inner portion? It is 60 plus 60. We are saying this length it is 60, this length it is 60, plus we are talking about the perimeter of this portion. Combined they will form a circle. So we are saying it is 2 into 22 by 7 into r, that is 2 pi r. Why 2? Because these are the two semicircle. One semicircle is on this side, one semicircle is on this side. So complete it forms a circle, and the perimeter of the circle it is 2 pi r, and this value is given to be 340. So we get that this is 44 by 7, r is equal to 340 minus 120, and the answer we have it is 220. So the value of r we have it is 220 into 7 by 22 into 2, this is 10, and the answer we get it is 35 meter. So we are saying the radius, this inner portion, the radius it is 35 meters. Now the first thing we have to find is the area of the track. Now look at this figure over here. We are saying the area of the track means we are talking about, we have two rectangular regions over here. We are talking about the area of the track. We have two rectangular regions. It is 60 meter, and the breadth of this it is 7 meter. This is 60 meter, and breadth of it is 7 meters. Next we have this much portion on this side and some this kind of portion on this side. So if we join both these portions, we are saying we are having a circular ring. The inner radius of this ring, it is 35 meter. The width of this track, it is 7 meter. So the outer radius of this ring we will have, it is 42 meter. So the area of this portion of the track, we are talking about the area of this portion of the track, that will be equal to pi into 42 square minus 35 square. Area of these rectangular portions we will have it is 60 into 7. So the total area we will get, we are saying we have two rectangular portions, it is 2 times 60 into 7, and the area of this circular ring it is pi into 42 minus 35 square. On solving these values, you will get the answer, it is 2534 meter square. This is the total area of this track. Next, the second thing we have to calculate is the outer perimeter. So for the outer perimeter, we are saying the length of this portion we have 60 meter, length of this portion we have 60 meters. So it is 2 times 60 meters. This value is shown over here. It is 2 times 60 meter. Now the outer radius of this portion, we are saying it is 42. So we are talking about a complete circle whose radius is 42, and the perimeter of this circle will be 2 pi r. Why complete circle? It is half semicircle over here and semicircle over here. So two semicircles when we join, we get the complete circle. and the formula for the perimeter of a circle, it is 2 pi r. It is 2 into 22 by 7 into 42, and the final answer we will get, it is 384 meters. So we are saying the outer perimeter is 384 meters. Now the next we have is ABC is a right angled triangle. This ABC, this is given to us, and it is a right angled triangle. It is right angled at B. This angle over here, this is 90 degree. We are saying this length AB we have, it is 48 centimeter. The length BC we have, it is 14 centimeter, and AC, this is the hypotenuse we are saying. So we can calculate the length of this hypotenuse, that will be square root of 48 square plus 14 square. The answer we will get, it is 2500 square root, and that is equal to 50 centimeter. Now next it is given that with AC as a diameter, this AC we are saying, with AC as diameter, we have drawn a semicircle. This is the semicircle we are talking about, and with BC as radius, we have considered this BC and radius, and we have drawn this quadrant of the circle. We have to find the area of the shaded portion. So it means we are talking about, we have to calculate the area. We are saying this larger area, this complete area we have to calculate, and we have to subtract from it this portion. We have to subtract from it this portion, that is this quadrant. So when we are calculating the area of this quadrant, we are saying the side we have, it is 14 centimeters. So area of this much portion, it is 1 by 4 into 22 by 7 into 14 into 14. And when we are talking about the area of this triangle, we are talking about the area of this triangle. The area of this triangle, it is half base into height. Next we are talking about the area of this semicircle. The area of this semicircle will be half into 22 by 7 into radius of this semicircle, it is 25 into 25. Now what we are saying is, we have a triangle in this form. We are saying we have a circular portion in this form, and we have a circular portion in this form. We have calculated the area of this portion. This is the area of this portion. We have calculated the area of the triangle. We have calculated the area of the triangle. So the total area we will get, the total area we are talking about of this whole figure, the total area of this whole figure we will get by adding these two values. Now if we subtract the area of this sector, the area of this sector we have calculated by using this formula. So we are saying we are having three values. The first value we will get, it is on solving these values, you will get the answer, you will get, it is 336. So we are saying the area of the triangle we have, it is 336 centimeter square. Next, the area of the semicircle we are having, that will be this area. We are saying on solving this value, you will get the answer is 6875 by 7. And on solving this first value, we are talking about, it is 1 by 4 into 22 by 7. On solving this value, you will get the answer is 154. So the final answer we will get, it is 336 plus 6875, it is area of this complete region, minus the area 154, that is the area of this sector. On solving this, you will get the answer is 1164.14 centimeter square, and this is the required area of the region. Next is find the area of the shaded portion. This figure is given to us and we have to find the area of the shaded portion. Now the next question we have to find the area of this shaded portion. So first of all we are considering this portion. We have shown this over here. We are saying this total length we have, this will be equal to 7 plus 7 by 2, that is equal to 21 by 2 meters. So if we are talking about this circle, we are talking about this larger circle over here, the radius of this circle will be 21 by 4 meter. So the area of this circle will be pi into 21 by 4 square. The area of this inner circle we are saying it is pi into 7 by 2 square. So area of this shaded portion, this first portion we are saying its area is pi into 21 by 4 square minus pi into 7 by 2 square. Next we are talking about the second region. We are saying this is a semicircle over here. This is a semicircle. The length, the total length we have over here, it is 7 plus 7 plus 3.5. So the radius of this semicircle, the radius when we calculate it comes out to be 35 by 4 meters. So the area of this semicircle will be pi into 35 by 4 square. It is pi by 2. These all values we are saying these are pi by 2. This value is pi by 2. These all values, these are pi by 2 because these are semicircles. So the area of this semicircle will be this. Next we are considering the area of this semicircle. The radius for this semicircle it is 7. So area we have it is pi by 2 into 7 by 2 square. This is the area of this semicircle. So area of this portion, the area of this portion we will have, it is pi by 2 into 35 by 4 square minus pi by 2 into 7 by 2 square. Now we are talking about this semicircle over here. This semicircle it has the radius 7 by 2. So the area over here it is pi by 2 into 7 by 2 square. So the total area we will have, it is the area of this portion, area of this portion, and this is the area of the third portion, and we are adding all these three values. These calculations, these are shown over here. This is the area of the first portion. This is the area of the second portion and the third portion, and you will solve these values. You will get the final answer. You have to multiply all these terms. It is 22 by 7 is there in all these values. You can solve, multiply these terms, cancel out this 7 over here. It is 7 5s are 35, 7 7s are 49. Multiply these terms and you will get the final answer as 144.38 meter square. So this is the required area. Next is in the given figure, triangle ABC is right angled at A. So triangle ABC is given to us and it is right angled at A. Semicircles are drawn on AB. We are saying we have taken this AB and we have drawn the semicircle AC and BC. On this we have drawn this semicircle, we have drawn this semicircle, and we have drawn a semicircle over here with BC as the diameter. It is given that the length AB is 3 cm and AC is 4 cm. So this length BC will be square root of 4 square plus 3 square, and it comes out to be 5 cm. We have to find the area of the shaded portion. So if we calculate this area over here, we are talking about this complete area of the semicircle, this complete area of the semicircle, second area we are talking about, and the area of this triangle. If we add these three areas, first we are talking about the area of this semicircle. Area of the semicircle means we are talking about it is pi by 2 into 3 by 2 square. The radius is 3 by 2. We are talking about the area of this portion. It is pi by 2 into 4 by 2 square. Next we are talking about the area of this triangle. It is half base into height. Next we are subtracting the area of this semicircle. We are adding these three areas. We obtain the area of this whole region. If we subtract the area of this semicircle, the area of this semicircle will be pi by 2. The radius is 5, so it is 5 by 2 square. So the answer we will obtain, that will be, when we solve these values, it is pi by 2 into 9 by 4 plus pi by 2 into 16 by 4 plus 1 by 2 into 3 into 4. This is the total area we have, and we are subtracting from it the value pi by 2 into 25 by 4. On solving these values we will get, it is 9 pi by 8 plus 16 pi by 8. Adding these two values we will get, it is 25 pi by 8 plus these two gets cancelled and we are left with is 6, and it is minus 25 pi by 8. So these two values get cancelled and the answer we are left with is 6 centimeter square. So we are saying the required area is 6 centimeter square. Now the next question we have is, in the given figure, two concentric circles with center O have radii 21 centimeter. These are the two circles. The radius over here, it is 21 centimeter, and radius of the outer circle, it is 42 centimeter. If the angle AOB, this angle is given to be 60 degree, we have to find the area of the shaded portion. So we are saying the area of this outer triangle, it is pi into 42 square. The area of this inner portion, it is pi into 21 square. So the area of the ring will be pi into 42 square minus 21 square. This is the area of this complete ring. We are saying this angle over here, it is 60 degree. So what is this portion corresponding to this circle? We are saying this whole angle, it is 360 degree. If this whole angle is 360 degree, the area is this. If the angle is 60 degree, the area will be 60 by 360 into pi into 42 square minus 21 square. So we are saying this portion we are talking about, it is basically the 1 by 6th portion of this complete ring. So the required answer is 5 by 6. What is this portion we are talking about? This is 5 by 6th part of the complete ring. So the answer we get, it is 5 by 6 into pi into 42 square minus 21 square. So when we calculate this value, we want to calculate the area of the shaded portion, we will get, it is 5 by 6 into 22 by 7 into, it is 21 into, it is a minus b into a plus b, it is 63. So we get 7, 3, 3 2s are, and this is 11, and on multiplying these values we will get the answer as 3465 centimeter square. So this is the required value. Or what we can do, we are saying this is the area of the whole ring, this is the area of the portion that is left. You can calculate both these values, you can subtract these values, and you will get the same answer, that is 3465 centimeter